Hello, welcome to week 2. Last week we learned about weathering, which included 4 types of physical weathering, 2 types of chemical weathering. So the 4 types of physical weathering, the most important is going to be abrasion. So abrasion in streams is the thing that rounds the sediments, which is why river rocks are nice and rounded and don't have many sharp edges. There's root wedging, which I made a little video about. I can post that. It's just when trees' roots grow between cracks and rocks and break them apart. There's frost action, which is in environments where things cool down below freezing and then thaw above freezing, where the water gets into the cracks and then freezes and expands. And then there's exfoliation, which we don't really talk much about. Don't worry about that one too much. The 2 types of chemical weathering, I don't know if you remember, but one was rust, right, which we call oxidation, okay, and the other is going to be dissolution or dissolving, where like acid can dissolve limestone and can dissolve calcite to form caves. But this week we're going to go away from breaking rocks or weathering rocks, and we're going to go into eroding the systems, eroding the rocks. So erosion is the term for the transport or movement of weathered material. Another way of saying that is just anything that moves a rock from one place to another is the erosional force. It's the erosion behind it, okay? So these are mostly caused by water, wind, and glaciers, and all of it has to do with the force of gravity. Water is moving downhill. Glaciers are giant sheets of ice that move downhill. And wind is influenced by changes of temperature, changes of pressure, right? Pressure high to low. But gravity is the most important one. So we're going to start by talking about gravity. So you might recognize a few of these types of mass movements. A mass movement is anything where a bunch of stuff is falling down a hill, essentially. So that would include landslides, avalanches, mud or debris flows, rock falls, and soil creep. So all 4 of the first ones, landslide's the most important. It's just a bunch of stuff coming down a hill. So now if you think about it, if there's just stuff coming down a hill, we're going to have a lot of what we call mixed or unsorted sediments. Unsorted sediments just means that who knows what will come down the hill. Big, angular, rectangular, right, sharp-edged boulders. And then even with it could come some sand and some pebbles, maybe even some silt and some clay, which is even smaller. But it's just mixed sediments, and they're not going to be rounded and smooth because they don't have that time like rocks do in a stream to break off all those sharp edges and smooth themselves out. So mass movements are unsorted sediments. They're not layered, and they happen due to gravity, the force of gravity. Okay? Soil creep is a little slower. So soil creep is the idea that you may have some rocks, right? So these are rocks, bedrock underneath, and it's on a slope or it's on a steep hill where the soil is slowly creeping year by year, maybe a couple inches or less, but it causes these trees to grow in weird J shapes because the tree gets pushed down, right? It gets pushed down the hill, but then it wants to grow back up. And then the next year, push down a little more, then it grows back up. So it forms this weird J shape in the trees, okay? So an example of a rock fall or a landslide would be what we saw before. So we have ice wedging or frost action, where water gets into the crack of the rock and ends up freezing, expanding, and cracking it off. So this is the after picture showing that it cracked off. Now, the breaking of the rock is called weathering, but the actual rock moving and falling off the cliff and coming down, that's erosion. Transporting sediments or transporting rocks is erosion, okay? Hopefully that makes sense. There's 2 videos in here that you can watch. Both are some interesting, scary landslide scenarios, but we're going to skip those. You can go in there on the notes on Schoology. I want to talk about running water. This is the most important form of erosion that we're going to talk about in this class. It's the most common thing that comes up on the Regents. And it's the idea that when water flows downhill, it moves things. So what I like to think about is when I have my hand and it's like dirty, right? Like I'm coming from inside, I was just hiking, I fell, I have dirty hands. The first thing I'm going to do is run water over it, right? So I have little specks of dirt, little specks of rocks on my hand, and if I have water moving over my hand, it will wash it off. But how do I make sure even the big stuff gets washed off? Well, if I turn my sink on low, maybe some of the stuff won't come off because the water's not moving fast enough. But if I turn it on high and a lot of water's coming out, that washes everything away. That's exactly what streams and rivers do. When the water is flowing slow, they slowly move the small sediments because slow water can only move small things. But as that water, or the discharge, the amount of water coming out of that stream, as that increases, we have more and more water flowing, it goes faster and faster. That's when it's able to pick up bigger and bigger and bigger rocks. And it's interesting that some streams flow so fast that they can move and roll boulders, and it sounds like a thunderstorm when we have giant boulders rolling through a stream. So when rocks roll through the stream, across the stream bed, abrasion happens, and we get those nice rounded sediments. So the erosion, or the movement of the sediments, causes the weathering, or the abrasion of the sediments in a stream. So just to be clear, the difference between erosion and weathering is breaking rocks, either chemically or physically. Erosion is going to be moving those broken rocks, okay? Erosion can cause abrasion, which is weathering. I want to show you this image. This is going to relate back to my next video. It's in a Nearpod, but I'll also post it on there. It's me standing in a stream explaining it. But if you've watched this stream, right, we call this a meander. A meander is a curvy stream, right? So this meander is a meander is a curve in a stream. It's not a curvy stream, it's a curve in a stream. So this meander forces the water to brush up against the outside of this curve, right? So we have the inside of this curve here, and then we have the outside of the curve. You can think of it as a track that you run on. You want to run on the inside of the curve, but water wants to run on the outside of the curve. Water likes to move in a straight line, and it doesn't want to turn unless it's forced to turn. So it pushes and it pushes and it pushes to the outside of the stream, where it brushes against the outside there, and then it's going to move down and brush against the outside of this curve and brush against the outside of that curve, and as it keeps going, it wants to push against the outside of the curve. What does this cause? There's a few things. The water on the inside of the curve is moving very, very slow, and slow-moving water has a hard time moving sediments with it. This outside of the curve, hopefully, okay, we're good. Let me just pick up where we were. Here we go. The outside of the curve is going to be getting a lot of fast-moving water, so it's going to dig down, take all those little sediments with it, and carry them downstream. This causes the inside of the turn. So let's imagine this is our curve here, right? The water's flowing this way. Since the water pushes to the outside and goes really fast on the outside of the curve, here is if I were like standing here, right? And I could jump into the stream. Where we have a curve, the outside of the curve gets dug deep because that water is carrying all those sediments out, while the inside of the curve is not so deep. So if I were asked to draw the surface of the water, right? So, I'm sorry, not the surface of the water. If I was given the surface of the water and they asked me to draw what it would look like along the stream bed from the inside of the curve to the outside of the curve, we're going to have, this is the inside of the curve, this is the outside of the curve. So just to give you some more understanding, like I'd be standing over here looking in at this. So where would I be more comfortable jumping in? Well, since the outside of the curve, the water's moving faster, the stream bed gets nice and deep there because there's a fast velocity. Fast velocity. So in this cross section, you're going to be seeing that the inside of the curve is going to be much more shallow, right? So because the water is moving so fast here, what used to be sediments and rocks all throughout here have now washed away, while the stream is flowing slow on the inside of the curve, so there's not enough speed for the water to carry things away. So if I were to jump into a stream, right, if I were to jump into this stream, this is a topo view, right? So this is from above. Would I jump in from this side to here, or would I jump in from this side here? So is the inside of the curve going to be safer, or is the outside of the curve going to be safer? So if we look, the outside of the curve is going to be deeper because the water has washed away all those sediments. So the outside of the curve is deeper because there's more stream velocity, and there's more erosion because there's a higher stream velocity. Alright, so just to be clear, meanders are just curves in rivers, and interesting enough, the steeper a stream is, the more straight that stream is. So young streams tend to be straight, or at least close to straight, while old streams that really erode an entire area, creating a huge floodplain where it can flood, these areas get very, very curvy, or meanders. And those meanders grow and grow and grow. And you can see that this is a time lapse from 1984 to 2012. And this is how a stream can change. So if you look here, right here, there used to be a stream that flowed over here, but it ended up touching, and now the stream has completely changed. So we have flow over here, watch this. This grows closer and closer, and then that changes the stream's path completely. So what this can cause are these things called oxbow lakes. Here's a picture from 1950 of a river, and it used to flow like this. But since the outside of the curve gets more stream velocity and more erosion, that means this curve is going to grow closer and closer and closer to this curve, to where today this looks like this. Because this curve ended up reaching and cutting off and going through here, and that cut off this entire area, which will eventually dry out. This is called an oxbow lake. An oxbow lake is an area where a stream or river used to flow, but it got cut off, and now it doesn't receive any water. This happens all the time, but it takes a long time. So this is a picture of the Grand Canyon, and you can see that eventually we're going to be having a cutoff here where this river flows around through here. It's going to end up cutting through here, and this will become a dried up oxbow lake. Okay? So watch my other video. It's in the Nearpod, but I'll also post it. It's me in a river, in a stream. Go to the Nearpod. The code is RQYMI. RQYMI. Go on to Nearpod, type in this code, open up the notes from Schoology, and you'll be able to complete all of this. Alright? Thank you. Have a good one.